Okay, so what we're going to do now is we're going to calculate the perimeter of this weirdly shaped pentagon. And to do that, we have to calculate the lengths of every side of the shape. So I'm going to start by labeling, not with a highlighter, every variable or every point. So A, I'm going to label this guy B, and I'm doing that so that my work can stay organized because I want to make sure that you can see like which points I'm calculating and where I'm actually calculating the lengths of. Um, so I'm actually just going to do the Pythagorean theorem in this one, but again, you can do the distance formula. I personally think the Pythagorean theorem's easier, so I'm going to start by calculating AB. So for AB, I'm going to draw my right triangle and calculate those lengths. I have 1, 2, 3, 4, 5 on top. 1, 2, 3, 4, wait, 1, 2, 3, 4, 5 on the side. And then I'm ultimately trying to solve for the length of AB. So I'm going to do 5 squared plus 5 squared equals C squared. And AB is the same length as what my C is technically denoting. So 5 squared, 25 plus 25 equals C squared. That means that 50 equals C squared. Take the square root of both sides. The square root of 50 is 7.1. So C equals 7.1, which means that AB is 7.1. All right, so from here, I'm going to do something very similar to calculate BC. So BC, I'm going to make my right triangle, and I'm just going to count those lengths. So 1, 2, 3, 4, 5, 6, I believe. And this guy is 1, 2, 3. And I'm just going to double check my counting because sometimes it's hard to read all those little boxes. So 1, 2, 3, 4, 5, 6. Yep. All right, so for BC, so that 6 and that 3 represents the A and the B of the Pythagorean theorem. And I should have written that up top before I started. So here's A squared plus B squared equals C squared. So I have 6 squared plus 3 squared equals C squared. 36 plus 9 equals C squared. That'll give me 45 equals C squared. And then the square root of 45 is 6.7. And I'm just rounding to the nearest tenth. Unless it signifies which to round it to, I like to do the nearest tenth just because it's clean, one decimal place, it's still rounded. All right, so for CD, it's a straight vertical line, so I can just go ahead and count what CD is. I don't have to do the Pythagorean theorem for that guy. So 1, 2, 3, 4, 5, 6. The CD is 6, and that's all I need to do. For DE, I have to make another right triangle, lots of right triangles on this one, and then just count. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. Doesn't matter which one is A and which one is B in the Pythagorean theorem because I'm adding the two together. So I'm just going to do 3 squared plus 8 squared equals C squared. And hopefully you're starting to get a pattern now of kind of what I'm doing each time. So that's going to be 73 equals C squared, square root on both sides. C equals 8.5. All right, one more. I know it seems like a lot, but we got one more to do. For this next one, another right triangle. If I can draw straight lines, we have 3 right here. And 1, 2, 3, 4, 5, 6, 7. Okay, and that's going to be EA. So these little lines over these names, over these variables, that actually represents that it's a segment. If I wanted to say it was a line, I might do arrows on the end of it. But these are just segments, so we're just going to keep that little length. So then we're having 7 squared plus 3 squared equals C squared. 49 plus 9 equals C squared. That's going to be 58 equals C squared. Square root both. C equals 7.6. Okay, and for the perimeter, ask yourself, how do I calculate a perimeter? Should be a fairly common answer. You add up all of the side lengths. So I'm going to take this side, which was AB. I'm going to add BC. I'm going to add CD. add DE, and I'm going to add EA. And once I add all of those 5 values up, I'm going to get the perimeter. So I'm going to do 7.1 plus 6.7 plus 6 plus 8.5 plus 7.6. Ultimately, my perimeter is, give me 1 second to add these together, 6.7 plus 6 plus 8.5 plus 7.6. And you should get that the perimeter is 35.9. And we don't actually have any units on this, but if we did, like centimeters or inches, it would just be inches, just be centimeters. So I'm just going to call this units because it doesn't actually have like a certain measurement. All right, I hope that made sense. Let me know if you have any difficulties.